Good day, folks. Welcome to my YouTube channel. This is the preliminary exam, which is it's a KZN September 2023 question paper. Let's cut the chase. It says an electrochemical cell set up under a standard condition using a hydrogen half cell and a nickel half cell as shown in the simplified diagram below. This is the electrochemical cell. Do you see this side? We have an unusual electrode here. This is the hydrogen electrode, which is the hydrogen half cell. This is the hydrogen half cell. In the hydrogen half cell, we have a platinum as an electrode here, which is this platinum here is only here to conduct electricity, and it's inert, which is by inert, which means it's unreactive. It doesn't react with anything, which means it doesn't form redox. It doesn't undergo reduction. So there are bubbles here, which is, if you see those small circles there, those are bubbles here, because this solution is made up of an acidic solution. If you see the H plus there, that means this solution is what is acidic. It's an acidic solution, right? That H plus, and it forms bubbles. So this is the hydrogen, right? So this solution, guys, it's under a standard solution, which means its concentration, it's 1 mole per dm3, and the pressure, because there are bubbles there, those bubbles, that means the pressure of those gases or those bubbles, it's 101.3 kilopascals, and the temperature is 25 degrees Celsius, right? And then we have a soul bridge there, which is labeled Q there. We know the function of the soul bridge, and we have a nickel half cell. The nickel half cell here, we have a nickel as an electrode there. And then if you note that we're given there a positive charge in the standard hydrogen cell, which means this one is a cathode. So this hydrogen here, hydrogen half cell is a cathode, and in this one, the nickel electrode, it's going to be an anode where the oxidation takes place. Right, let's answer the question. State standard conditions besides temperature of 25 degrees Celsius under which the cell operates, which means I've already mentioned that it's the concentration of the cell, which is it's 1 mole per dm3. The concentration, it has the concentration of 1 mole per dm3, and it has a pressure of 101.3 kilopascals. That's the pressure. Now 8.2, it says calculate the initial reading of this voltmeter. So let me calculate it here. The 8.2, it's 8.2, it's E cell is equal to the cathode minus the anode, right? So the cathode here, if you look in the table there, we have hydrogen and the nickel. Here's the hydrogen and here's the nickel. The nickel is 0.27 and the hydrogen is 0 as a cathode. So the cathode is the hydrogen is going to be 0 minus, and the anode, which is it's negative 0.27, which is going to be 0.27 volts. That's the initial reading for that. It says for this chemical reaction, write the energy conversion. The energy conversion in the galvanic, it's chemical to electrical energy, right? Write down one function of component X. The component X, which is the soul bridge, it completes the circuit. The soul bridge, it completes the circuit. Now it says write in 8.3.3, write down a direction in which the N ions in component Q, which is in the soul bridge, will move which direction? Choose towards the nickel cell half cell or towards the hydrogen half cells. Guys, all the time the N ions through the soul bridge, they move from an anode, from the N ions, they move to anode. So the N ions they move to anode, which means the N ions, they're going to move towards the anode. So the anode is the nickel half cell. So the answer here, it's going to be, I'm going to underline it, it's going to be towards the nickel half cell. Now 8.3.4, write down the half reaction that takes place in an anode, which is the anode is the nickel. So the half reaction for a nickel, since it's oxidizing, it's a nickel atom to a nickel ion with the 2 electrons there, which is the same as this, guys, this one, right? Okay, now let's go to 8.4. 8.4, it says, how will the pH of the solution in hydrogen half cell be affected? Choose increase or decrease or remain the same. Explain your answer, guys. As I've mentioned, that this cell here, it's the hydrogen half cell, and it has an acidic solution. So the pH of the solution here, its pH, it's what? It's low. It's low. Now, as the cell operates, because the hydrogen there, it's undergoing reduction. What do I mean it's undergoing reduction? It's a hydrogen ion, it's reduced, and it forms what? The hydrogen gas. So the hydrogen ions that are there, they are reduced to hydrogen gas. That means the concentration of hydrogen ions there, it's decreasing. So if the concentration of hydrogen ion is decreasing, that means the acidity of that solution is decreasing. So if the acidity is decreasing, that means the pH is increasing. So the answer here, the pH is what? Is increasing. Why? In 8.4, so what I'm going to say there, I'll say the hydrogen is reduced to a hydrogen gas, as you can see from the half cell. And then the second point there, you will say the concentration of H plus decreases. It decreases the concentration of hydrogen ions there, it decreases because it's reduced. There's a reduction that is going on there. Now, if this half cell, it was an anode, so it was going to be the hydrogen gas oxidizes to hydrogen plus. That means the concentration of the hydrogen plus we're going to increase, and then the pH was going to what? Decrease. Right, let's answer 8.5. It says the platinum electrode is replaced with a larger platinum. How will this affect the initial EMF? Choose increase or decrease or remain the same. They say here this platinum is replaced by a bigger platinum there. Remember, this platinum is only there to conduct electricity, nothing else. So it will have no effect there. It will have no effect because the platinum is inert. The platinum is inert and is there for conductivity of electricity, even though they did not ask for an explanation. Right, I hope that makes sense, guys. Cheers, bye.